Hey guys, welcome back to chapter 11. In this video, we're going to do just another example of vapor pressure lowering. This one's ramped up a little bit because we've got to determine a couple more factors than we did in the last one. So here's our problem. Calculate the total vapor pressure of a solution made by dissolving 25 grams of glucose and 215 grams of water at 50 degrees Celsius. If you would like to challenge yourself, go ahead and pause the video and see if you can work it out. If not, I am going to work it out with you. All right, so first things first, this is a vapor pressure question. I know that I'm going to use Raoult's law. So Raoult's law, put my pen here. So Raoult's law is the pressure of a solution equals the mole fraction of the solvent times the standard pressure of that pure solvent. So on the next slide, I'm going to take inventory of what I know, decide what it is I'm trying to solve for. So we've got pressure of the solution, we've got mole fraction of the solvent, and we've got the standard pressure of that pure solvent. So clicking back, calculate the total vapor pressure of a solution. So not surprisingly, the piece that we are trying to solve for is that pressure of solution. So I must know the standard pressure of the solvent, and I must have enough information to do this mole fraction piece as well. So I come down here at the bottom of my slide, and I see the vapor pressure of water at 50 degrees Celsius is 92.5 torr, and we are at 50 degrees Celsius. So that's going to be that standard pressure of the solvent. So I'm going to go ahead and plug that in here. 92.5 torr. All right, so this mole fraction piece is going to take a little bit of work this time. So mole fraction of the solvent, remember, is moles of solvent divided by total number of moles in the solution. So going back, I don't see moles anywhere in this problem. Okay, I see that I dissolved 25 grams of glucose. I see that I have 215 grams of water. None of that is moles. But I am a seasoned chemist, and I know that if I'm given grams and whatever the substance is, I can go from grams to moles. So that's going to be the first step in this problem, is taking 25 grams of glucose, converting it to moles of glucose, and taking 25 grams of water and converting it to moles of water. So let's go ahead and do that kind of down here. So if I remember, 25.5 grams of glucose. So C6H12O6. So grams on the bottom, moles on the top, and 1 mole. And I was a very, very kind instructor. I gave you the molar mass of glucose, so you didn't have to go figure that out. But there's 180.2 grams in 1 mole. So 180.2. So multiply across the bottom, multiply across the top, divide by the bottom. So 25.0 times 1 divided by 180.2, and we get 0.139 moles of glucose. All right, and we're going to do the same thing for water. I'm just going to pick a slightly different color. So for water, we had 215 grams. Grams of water. Again, grams on the bottom, moles on the top. And again, I also gave you the molar mass for water, 18.02. So oh, no, just kidding. So let's fix this here. Alrighty. 1 mole is 18.02 grams. Multiply across the top, divide by the bottom. So 215 times 1 divided by 18.02. And we see that this is 11.9 moles of water. All right, so now we need to use these two mole numbers in our mole fraction equation. One thing to point out here, I kind of know that water is the solvent in this case. I know water is the solvent because water is typically the solvent. It would be silly for sugar to be the solvent. But let's say I was dealing with two things that I wasn't familiar with, or maybe it was like two liquids, right? So it also says 25 grams in 215 grams of water. But what if I was dealing with stuff that I wasn't familiar with or wasn't clear in the problem? Now that we have gotten to a common unit, when we have moles, that's like comparing apples to apples. Here I see that I've got 0.13 moles of sugar. I've got 11 moles of water. That also tells me that water is in the greatest proportion and sugar is in the lesser proportion. So that's a good way to kind of decide what's the solvent, what's the solute, if you're not familiar with it. Okay. All right, so up here to my mole fraction of solvent. So my total number of moles is going to go on the bottom. So that's taking the 11.9 moles of water and adding it to the 0.139 moles of sugar. So I've got 12.0 total number of moles. And then on the top is going to be the moles of my solvent, whatever is in greatest proportion. So that was our water. So we've got 11.9 divided by 12. And the mole fraction is 0.992. So that's going to come over here. So a little bit more work in this problem to get to the mole fraction. We had to first solve for the number of moles of each. And then put that into our kind of mole fraction equation. But now that we have mole fraction, we have that standard pressure, we can finally plug it into Raoult's law and get our pressure of solution. So we're going to have 0.992 times 92.5 torr. I know this answer is going to spit out in the unit of torr. And I'm also going to expect that 92.5 to go down, right? Vapor pressure lowering. So 92.5 times 0.992. And we see that our answer is 91.8 torr. So that is an example of Raoult's law. That's about as difficult as I can make Raoult's law. So hopefully you guys will find some practice and do some on your own. I hope you guys found this helpful.